Everyone, welcome back to our Solidworks tutorial. Quickly in this tutorial we're going to be working on this very model. Basically this is an assembly in Solidworks, and this assembly consists of three components, and among the three, two of it were duplicated to form the assembly that we all are seeing right here. In excess, what we have right here is just a plate and a bolt, and also this last plate over here. This bolt has a specification as illustrated by a manual, and as for the plate, if we can scroll up, we will see the single plate and its 2D demonstration or illustration. As for the plates, it has its own geometry, and according to what was given to us, we are going to draw this thing by its specification. So as you can see, this plate has 4 holes. So 2 of the holes are kind of smooth and the rest of the 2 are kind of threaded. So we're going to do some real work on this very model, and let's see how we're going to achieve that. So before we do that, let's first design this sockets, and then let's see what it's going to provide for us. So I want you to pay attention to this metrics specification, because we're going to be needing it for this very bold design. So let's jump to Solidworks. Now we're in Solidworks, and then the first thing we do is you select your plane, and then we go to your sketch, you draw a circle. So I'm going to give it a random number. I'll just give it 12. So now from our manual, it was given to us by this specification, which goes by M12 times 1.2 times 20. So for those who are conversant with engineering terms or mathematical terms, the M stands for the diameter of the bolt, and also the 12 stands for the pitch, that is the thread distance between the successive distance between the 2 threads, and also this 20 is the length of the cylinder that is formed by the diameter. So from Solidworks, you could recall that this circle now is already 12. So now I'm going to extrude to 20, because it should be extruded to 20 as given to us by our metric specification. Now this is actually the cylinder, and then the next thing to do is to give it a threading geometry, just for it to look like a bolt. Now in order to achieve that, there's a function in Solidworks called the O wizard. Then once you click on the O wizard, you click on the button below it, then you will select the thread. So the Solidworks now will provide this dialog, which will make us to customize this very cylinder to a thread. So now the first thing you do is that you select the surface where the threading will start from. So you select any of the edge, or any edge of your choice. So I'm going to select this edge. Now you can see some icon view of a thread formed around the cylinder. So then the next thing we do is that we go to our specification. So according to the manual, the specification is given to us by M12 times 1.25 times 20. So I'm just going to change this very thing over here to M12 times 1.25. So if you can click this thing, you will see all the available specification that it can be confined to. So I'm going to look for the M12. All right, so this is the M12. Now the M12 is shown to us right here, and anything that has to do with bolts is going to be metric die. So you have to take note of that. We are working with metric die once we are dealing with bolts. So now from this region, we can see that the 12, it shows the diameter of this model, and the 1.2 shows us the distance between the two successive threads. So that's like, in other words, it's like the pitch. So from there, then we move to this region called the offset. Now the offset is like the distance from this edge to where it is right now is the offset. So now I want to make the offset. I want to ensure that this thread takes half of this very model. That is, the half of this model is like 10 millimeter in height. If we can divide this cylinder into half, so I want to make this thread to take the half portion of this cylinder. So that therefore I'm going to make the offset to be 10. So remember, the overall length is 20. So now the half of this is already 12. So from there, I think we are literally done with the threading of this very region. I'm just checking if there's anything that needs to be done. Okay, so this is actually the thread. Now there's one thing that you need to know. This very region is actually how far the thread should go. So once I actually reduce this thing, you will see how it has been elongated. So I'm just going to click 20 to see where it's going to lead. So now I've increased the threading icon to be 20, but this is actually where the thread is going to be affected on. But this one is actually emptiness. There's nothing going on over there. So after finish with all this thing, then you just save. Now we can see our bolt is gradually forming. So from the manual, we could see that this is a bolt, and if you consider an X socket bolt, it has some unusual kind of shape. It's not just the regular bolt that you use your spanner to turn, to twist, to draw what you want to do. It has its own special kind of configuration. So I guess you should just browse it and see the nature before you continue with Solidworks. So now I'm going to draw the cap and also the keyway where it's going to the necessary driver is going to be connected to. So now according to the manual, I don't think there's any instruction on how we can draw the cap. So I'm just going to go to my circle and then select the center line, and I give it let's say, remember the overall circle of this is 20 is 12, right? So let's just give it 15. All right, I think 15 is small, so I'm just going to increase it by clicking this very section, then I drag my mouse. Now since it is not yet, I've not assigned it to any kind of dimension, so I can drag it to any choice of my any extension of my desire. So now we have increased this thing. Now I'm going to just give it its own shape. So I think this one is fair enough for me, but you can increase it to anything of your choice depending on what you wanted it to be. So now this is actually the cap. Now on the cap, I'm going to draw the keyway where we can plug in our socket, our screwdriver, or anything that is that can be used to twist this thing around. So there's another sketch here which is called polygon in our sketch. Then I just remove from there and then place at the middle. to draw out the polygon. So the polygon is already formed, and then I just extrude cut. So I'm just going to ensure that the cut is not more than the cap itself. So having done that, then I save. So as you can see, this is an X socket. So if you can Google it, this is actually how it's going to look like. So as far as this model is concerned, if you follow all my instruction, then you should be able to draw this X socket all by yourself. So now what I'm going to do now is that I'm going to save this model. I just name it X socket X bolt. I think I've saved it before, so I'm going to save it as capital letter S bolt. So we have saved it to be as S bolt. Okay, let's just say X bolt 2, because I've done it before as is given to us by Solidworks. So now we are done with this very model. Now back to our manual. We have completed with this very bolt. So now I'm going to design this very plate using the instruction given to us. Now from the instruction from this very model and back to the 2D sketch, we see that the model has 4 successive core, and also it has a fillet that was distributed round about it, and also it has the O with its own specification. So here one of the O is smooth and the other one has its own thread, just like what we did to the bolt, but this thread now is drilled just like a nut inside the plate, so that when we're done we will be able to screw the 2 model together to form a assembly of that kind of nature. So now with this, I want you to picture it and then sculpt your mind. Then we are going back to Solidworks. So back to Solidworks. So from Solidworks, I just go to my parts, then it begins with a sketch. So now from this 2D sketch, we see that this is a rectangle that has the overall length of 100mm by 50mm, and we have a O that are positioned in their respective coordinates, and they didn't give us how to position this very circle, but there's a trick that I have used to achieve that. That is, I'm going to position it by an invisible rectangle to space them accordingly. But first of all, let's just draw this rectangle and see what we can do from there. So you go to a circular rectangle, then smart dimension 100 by 100 by 50, so 100 by 50, and it is extruded to 10mm. So extrusion is 10mm, and then that's it. So the next thing we do is that I draw my circle, and each circle is at 10mm. So before then, I'm going to draw the line that will space them accordingly. So this I'm going to do it, and I'm going to tell you the reason why I did it that way. So now there's a circular rectangle over here, and then I I ensure that this becomes 60, and then this becomes 40. Okay, not 40, 25, 25, and then I'm going to make this a all construction line. So in case of next time, you just go to the middle, and then this whole rectangle is going to be highlighted. So once highlighted, just right click on your mouse, and then you'll see a dialog over here. Then you go to this section which is called construction, and then you make it a construction line. So now it's not a construction line, it's invisible. Then I'm going to draw my circle. So each circle is 10. This one too is 10. So I want to show you something. So why did I draw the rectangle of that kind of finisher to position it at the extreme point? Now from the look of this sketch, we see that the overall length of this very rectangle is 100 millimeter, right? So now the only distance that will reveal to us was the distance between this very point to the end of this line, which was given to us as 20, and the same thing too goes for this very circle. The distance from this point to this end is 20. That is, if 20 is the difference between here and this point, that is from this very point to the end of this point should be 60. So in excess, 20 plus 20 is 40. 40 minus 100 is 60. So the overall length of this emptiness here is 60. That's why when I draw my rectangle, I specify it to be 60. And now the distance from this point to this point is 25. That's why the breadth of the rectangle now is 25. And then at the end of everything, I plugged in my circle at each of these points, because automatically where this point intersect is actually where the circle is going to dwell. And that's actually how I was able to do that. So try it. And also there are possible many ways to achieve yours. So any way that is convenient with you, you can try it as well. So from there, I'm just going to extrude cuts. And that leads me to another thing I'm going to show you. You can extrude cut by literally dragging this arrow down here, or you can just click this thing over here, and then you see all the options it has for you. So we currently, by default, you're working with blind, but I can change this to show all, and then you do not need to drag it anymore, because as the instruction was given to you, once it's given to us as true all, then it will cut through everything. So you do not need to drag anything out again. Then you save. So now our circle now is formed. The first circle now have been formed. So the next thing now is to give it a fillet. So fillets in the sense that each of these parts were giving some kind of smoothness, some fillet, which makes it the model we see today. And each fillet is given to us by 1 in 45 degree, and also the fillet around the side is also 1. So now back to Solidworks, go to your fillets. So I'm going to highlight all of these edges. And then from our manual, it's going to be 1. Then save. Now the first fillet is already formed. Then I'm still going to go to the fillet again. I'm going to click all of this line. Okay, so I'm going to delete everything. So I'm going to do it again. I'll click this line. And now our fillet is now rounded. So click here, and then the fillet is already formed. So again, if you can look very closely, the circle also has its own fillet. That is, each of this circle has its own fillet, and each fillet is given to us by that same specification. So back to SolidWorks. Now you select the fillet again. You select the fillet again. Then it's going to be 1. And then that is all. So now what final thing that we're going to do is that I'm going to thread this region and see how we can give it the final touch before we save this very model. So the thing we're going to do is that you're going to go to your O wizard, and then you go to your thread, and then you click this very edge. So you have to take out of something. You're gonna have to click this edge. You're gonna have to click this edge, this very edge, not the one that we're giving the fillet, unless it's going to give you a wrong geometry. So I'm going to click this edge, and now the thread is already formed. So just like how we did to our bolts, we're going to have to do the same thing, but we're going to follow it with a different metric specification. Now the metric specification for this very model is M10 times 1.2. So that is the diameter of this circle is 10 millimeter, and then the distance between the pitch is going to be 1.25. So now I'm going to go to this very place, and then I change it to 1.25. So we're going to look for 1.25 over here. Okay, M10 times 1.25. So it has been corrected. And also we're gonna have to change it to metric tap. So anything that the screw will, the bolt or the screw will get in contact with it needs to be in metric tap, not in metric dive. So as compared to what was given to us, as compared to the bolt, we're gonna have to change to metric tap. Okay, sorry, this is inch tap. There's a mistake somewhere. It's supposed to be metric tap, not inch tap. That's a mistake for that. So I'm going to recalibrate this thing again. M is going to is supposed to be M10 times 1.25. Now it's something that we now can remember. So from this, I think the threading is gradually forming. So from the look of things, I think we're already done with this. Now we can see that the thread is formed. So the next thing, we're going to do the same thing over here, but instead of we wasting our time to redo all the process that was being done on this very moment, we can actually copy what we have done here to this very model, and that will be possible by using the mirror entity. So mind you, from our previous teaching, the only mirror entity that was discovered that I have let you know is the one of these various type, that is the sketch. Under the sketch, it has its own mirror entities, but under the feature, you can also find your mirror entity. So this is the mirror entity we're going to use, and then in the mirror entity, the first thing you're going to do is that we are going to select the plane where the model will be mirrored into. So now the reason why you're going to have to select the plane is that we are going to, the plane serve as the line where the mirror will be shared into. So now, as if you can recall from our last period, if you want to mirror in Sketch, we're gonna have to draw a line in the middle. That is, the distance from here to the middle will be the distance from that middle to the very plane that you want the model to be situated. So the plane will serve as the line. So you don't need to draw a line. So the line will not work in this very function. It's only the plane that we're going to work. Now the only thing that separates this very model, that cut it into half, is actually the top plane. The top plane. So once you are done with the top plane, you create the top plane, and then the top plane is formed. So the top as the distance from this very thread to this very thread. So we'll select the top plane, and then the rest, then you move straight to features to mirror. You click your features to mirror, and then you select your thread. So I'm going to select my thread. Now the thread has been copied from this very region to this new region. So if you can see very well, the thread has been formed. You need to draw all those things and go through the stress all over again. So now we can see this is actually the finished model of this very plates. So let me check it again if there's anything we've forgotten. Okay, I think we are done. All right, I think there's a mistake somewhere. So I've realized that the fillet for each of this hole is not 1 millimeter. It's supposed to be 0.5. So that's a mistake. Now that it's kind of obvious, whereby the fillet looks too much than the actual model. So I'm going to go to my fillet, and then I'm going to readjust it from there. So it's going to be 0.5, 0.5, then all right. So now I think we are now done with this very model. So from there now I can save it as plates, or yeah, let me just call it plates, yeah. So you can save it as anything you want. So in my next video, we're going to go to assembly, how we can screw the X bolt to this plate. So with that, I think that comes to the end of this video. Thank you for your time, thank you for listening, and see you in my next video. Bye for now.